I end up with 9, so 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. What's 10% of 29? 2.9. So I would expect somewhere around 2.9 intervals to not contain the real mean. The real mean was 80.297. That's the real mean of all of this. And it ends up that how many of these intervals don't catch that? 2. We expected 2.9. 2 of them ended up not catching it. You guys, I'm trying desperately to get you to see. I'm hoping the conclusion we write makes more sense now. If you were to create several intervals using the same population, that's exactly what we just did. What percentage of them would catch the real mean? 90% in this case. And we can see roughly 10% don't catch it. Okay, maybe. My other class, it was 2 of them, and then they ended up with 6 of them didn't catch it. So anyway, that was still within the same realm. All right, guys, does that make sense a little tiny bit? At the very least, it was practice with 1-var stats, looking up t-scores, good practice. But the next level of what I tried to make out of that was, why do we say the conclusion the way we do? What does it mean when I do this? That's what it means. If I did several of them, or if I had several different groups doing them, 10% wouldn't catch it. Okay, I like it, yes.
So just clarifying, because I have to change my answer for the part square root of n. N is, would it be like 330?
What was the very first thing you did?
Or would it be the sample?
Very first thing you did. What is it you're working with?
The sample.
20 numbers, right? You didn't work with all 300 whatever. You worked with 20. That's your end. I like it. Okay, now, moving on. As always. Alright, so I think I got that. I might want this for later. I'll make sure I get this. I don't know if I'm actually going to use that. We'll see. Any questions about what we just did at all? Okay. I mean, one thing you could see right away is very few of these would have been the same, which is understandable. Everybody would have gotten a slightly different sample mean. Everybody would have gotten a slightly different sample standard deviation, right? You all use the same t-score. What's the t-score you should have used? 1.729. So I noticed a few of you guys had looked it up a little bit wrong, but it should have been 1.729. So make sure you see why it should be that. I always appreciate the little faces up there. All right. So, what we're getting into now is something called hypothesis testing. Guys, you all know the word hypothesis. You all know a horrible definition for it is educated guess. That's close enough for the most part. Right? A hypothesis is some kind of claim that we make, right? So if I claim that, let's see. If I claim that, let me use this one that I used with some students earlier. If a friend of mine claims that everybody on this island has an average height of 7 feet tall, right? This little island somewhere. And he says, oh yeah, if you go there, the people there average 7 feet, right? You guys with me still a little bit? All right. So we go there. Why not? Right, well, I got tons of money. Let's charter a private flight to this little island. It's a joke. I don't have tons of money. Somehow we make it there, right? We stow away in some ship and then we swim there. I don't know. And we get there and I take a sample of 50 people on the island. And that sample has an average height of 5 foot tall. what do I think about my friend's claim?
He's wrong.
It looks like he's wrong. He claimed that everybody on the island had an average of 7 foot. I take a sample of 50 people. They average 5 feet tall. That is good evidence that he's wrong. Why is it not proof that he's wrong? It's not proof because it's only a sample. Could I have possibly randomly picked the shortest people on the island? Right? Is that possible? Yes. Is it likely? Especially if I did it really randomly. Now, if I only went to a certain building and I took people out of there, it might have been the short people meeting or something on the island. You know, the 50 shortest people are like, all these crazy tall ass people. Right? Are you guys kind of with me? But if I really took a random sampling of 50 people, that would apparently seem to be good evidence that he's wrong. So the whole idea of hypothesis test is there's a claim that's made. I go gather a sample and try to see, is there enough evidence to say the claim is wrong, or is there not enough evidence to say the claim is wrong? Why can't I prove this to be right? Well, for example, in this example, he said that their average height was 7 foot exactly. If I took a sample and the sample average was 7, is that proof? Let me say this again. He says they're 7 foot tall. I took a sample and my sample average is 7 foot tall. Exactly. Why is that still not proof that he's right? Because again, it's just a sample. A sample can never prove that average equals something. Does that make sense? No? So if I have a feeling about the average age of gross month students and I take 800 gross month students and get an average age, that has nothing to do with if it's equal to the population average. Are you guys kind of with? I can only show evidence that it's somehow not equal to something. Like in this case, he thought it was 7. We found really strong evidence that it actually is less than that. Is the actual average 5? I don't know. Could be, right? So there's nothing in here about proving something one way. It's just evidence that some statement is, in this case, wrong. Okay, how are we doing so far? I mean, we kind of know how this works. You've all seen stupid crime shows, maybe some good crime shows. Most of them are stupid, enhanced bullshit. You try to gather enough evidence to show that somebody did something, right? So either you find enough evidence to say it looks like they did, or you don't find enough evidence to say it looks like they did. Right? Yes? So if a courtroom finds you, they don't find you innocent, do they? They find you not guilty, which, believe it or not, is different. It just means you could have done that shit, but we can't say you did. So go on back out in the world, right? You guys semi with me a little bit, a little tiny bit? All right. We all know what happens. We do the best we can. So, if there's a claim, there must be some kind of a counterclaim, like something I'm fighting against. So let's use this example of the 7 foot tall people. So the claim that he made, oh man, are you dying? Was that their average was 7 feet, right? So what is he kind of inherently fighting against? The idea that the average is not 7 foot tall, right? So this is the claim, and then the opposite of that, or the opposing claim, would be not equal to 7 feet. All right, that kind of makes sense. Any claim that somebody makes, I claim that my toothpaste works better than any toothpaste out there, right? So the opposite claim would be, your toothpaste is at least as good, or at most as good as every toothpaste out there. You guys with me? A little bit? A little bit? All right. So the very first step in this, there's going to be 5 steps in these. When I was taught it, it was 8 steps. So I chopped it down to 5. You're welcome. Just deal with that shit. There's 5 steps to these things. The first step is all about just tell me what you're talking about. Set up your hypothesis. There's a hypothesis H naught, officially known as the null hypothesis, heretofore referred to as the hoe. I'll say null, I'll say hoe. If I offend you, just wait a few minutes, I'll offend you again. And then the other one, most books have it as the ha. This book has it as the high. So yes, we have the hoes and the highs. Those are just the two opposing arguments, the two opposing claims, right? Specifically, stay with me now. What did I say earlier about an equality statement? Can I ever prove an equality statement using a sample? No. Hell no, right? You definitely can't prove an equality statement. You can show evidence against it. I do have a handout that's got all the steps, but I'm trying to get enough up here. This guy is always going to be the statement that has an equal sign in it. This one is going to be the one I can actually show evidence for, so it can't have an equal sign in it. Because what we just say, you can't prove equals. Maybe. So what's going to go in for the hoe? Obviously, what I just said was it's got to be the one that has the equals. So it's going to have to be this. So this one is going to be the opposite. So I don't know, I could say this. I always think about these as two little old men in a coffee shop. And they're arguing. Oh yeah, well I think he should be impeached. Well, you're full of shit, man. He's my man. So it's two opposing viewpoints, right? They're always opposite of each other. Okay, I like it. So let's do another example of just this step. Real quick though, if we go to that island, 5 feet seem to maybe be evidence that that's wrong, right? That this is right. But tell me, where could it be? 5 feet seems like it's evidence this is wrong, that this is right. What else could do it? What if I went there and I found that they were get off the plane or swim up to the shore and 9 foot tall? I'm like, what have I done? What? All right, please be friendly. You guys kind of with me? Because not equal to. What does not equal to mean? It could either be bigger or smaller. So how many tail test is this? 2 tail, because either way would show evidence for this guy. Now watch this. What if I had a claim that some drug works faster than another drug? So like one drug takes 11 minutes, and I claim that my drug works faster. So what's my claim in Mathish? My drug works faster. Yeah, mu. So the average time of my drug for everybody, mu, would be less than 11. Which one is that going to go in for? The hoe or the high? The high. I love it. Because what's the hoe always got to have? That. Oh, jeez. That's a weird statement. What's the null hypothesis? Always have to have evidence in its statement. Huh? Equal signs. Does the thing we just wrote down have an equal sign? No. So where's it going to go? The high. 11. What's the hoe going to be? No. Greater than or equal to. This book is interesting. Some books will say it's always equal to, and they're wrong. This book, sometimes it has equals and sometimes it has the actual opposite. It should just always be the opposite. I'm sorry.
So if one is like less than 11, will it just be greater?
Or equal to. One of them has to include the equal to. Why are these two statements not opposites? Because together they don't cover everything. Together they leave out 11. So if this guy leaves out 11, the opposite better include 11, right? And then that kind of goes along with what I said. What's the hoe always going to have? The equal sign, 11. Learning so much, aren't we? You guys, so on this one, again, remind me, which statement can I actually show evidence for? Always. The high. What would show evidence that this is true? If I gave this drug to students, sounds great. What would I want to see happen to show evidence for my claim? To show evidence for this. I want to see the time it takes for them to get better to be less than 11, right? So where on the picture should that show up then? Is that okay if it's up here? No. Only down here would show evidence. I like it. So that would be a one-tail test. And now you see why the T-score chart has one tail, two tail. Confidence intervals are always two tail. Hypothesis tests could be one or two. Depends on what it is you're working with, right? Okay, maybe. Okay. That's step one. Yes?
Would you ever do the opposite for like the greater than or equal to? Like for the other formula would be like that's for the high formula?
So if my claim was the mean is at least, let's say the claim is at most 9. If that's the claim. If I claim that at most 9, I'll have at most 9 holes in one next year. What does that go in for? Where do I put it? In the hoe. I like it. Right? You put that statement into the appropriate spot next to the null hypothesis. Right? Or it goes in for the hoe. Why did I put it there? Why did you tell me to put it there? It has an equal sign. And what's the opposite of that statement? No. Greater.
Sorry, greater.
That is less than. So the opposite is greater.
But I mean, like, would you ever do a one-tail test for the hoe or like that statement? You know, you said you would.
So let me say it again. What's the only one of these that I can actually show evidence for? The high. Because the hoe has an equality statement to it. And I can never show evidence for equality. I can only show evidence against equality. That sounded horrible too. We got hoes and down with equality, all that kind of stuff. Wow, what a great series of sound bites somebody could use against me if I ever run for Senate next. Okay, all right. So again, the first step in any hypothesis test is just setting up what the hell you're talking about. And again, how many tail tests would this be? To show evidence for this, my sample would have to only be above 9. Right? Now, here's the next thing. I just got a few more minutes. So that first example I gave about the height was kind of extreme, right? He thought it was 7 foot tall. We saw a group that was 5 feet tall. That's obvious. Are those close? Would you say his guess was close? No. So somebody, right? Is that? I guess it's 7 feet, and then it turns out to be 5 feet. Is that close? No. Now, close is an interesting word, right? You can't just say something's close. We know in statistics, how do we measure distance in statistics? We use standard deviation to create a z-score. Z-score is a measurement of distance. You guys with me? Stay with me. Okay, now. So if I said I claim that is an average of 7 foot tall, and we take a sample and we find an average of 6'9", is that strong evidence that he's wrong? It wasn't 7, was it? But in this case, it was pretty damn close. Now again, to be really honest, we shouldn't be able to answer that question. I don't know how to measure closeness until I know standard deviation. So for example, are 12 and 14 close? You should sort of know the answer to that is I don't know. What if the standard deviation is 0.1? 12 to 14 would be 10, 20 steps. The z-score between them would be 20. Holy shit. So 12 and 14 then would be light years apart. But if the standard deviation was 5, 12 and 14 are even a full step apart. You guys with me? So we inherently understand that when somebody makes a claim, there's an idea of closeness. If I claim that I can guess the right card when you pick a card, and I can guess it using my mental abilities. If I claim I can guess it every time, and you do it 50 times and I get 49 of them right, are you going to go, whatever, man, full of shit? Or are you going to go, dude, well, let's use this. You've got powers, right? Of course you are. Holy shit. But if you do 50 times and I get 3 of them right, obviously I'm full of shit, right? I did worse than guessing. Damn. No, yes, maybe. Maybe no, maybe no. In fact, later this semester we're going to test each other to see if we have ESP. So we're going to analyze the results using hypothesis. And last semester, a girl, so I pair you guys up, you guys do the test, and I say, if anybody reaches the threshold, I'm going to test them myself. And she passed both times. And I was like, I got to start wearing tinfoil hat or something so you can't see the answers to the test in my brain. Don't look in there. Are you guys at all with me? She apparently had evidence that she had ESP. And when I retested her, she still had evidence. And that's freaky as shit. A little bit. Anyway, anybody ever seen the original Ghostbusters?
Yes.
Yeah.
And they have those cards at the beginning with the little wavy lines and stuff.
Yeah.
And the guy's like, you getting them all right because he just wants to go on a date with her. But those cards are the official ones you use for ESP testing. So I'm going to use those cards later this semester. What are you guys packing up for? Spoiled you guys so much. It's not time to go. Okay. Jeff, you're so good stuff. So this idea of closeness is important. So for example, in this problem, if I took a sample and I got 9.2, and let's say the standard deviation is 1, is that very far away? Is it bigger than 9? Is 9.2 bigger than 9? Yes. But why can't I just stop there and say, I proved it. Next issue. Well, global warming. Let's do that shit. Right? So that's bigger. But is it bigger enough? Since I'm only using a sample, not only does my sample have to be actually bigger in this case, it's got to be bigger enough to be evidence. Just like we were saying right now. If I want to prove somebody doesn't have ESP, they're going to have to get far enough away from the number of guesses that would show there so to be evidence that they don't. So in this case, these are not very far apart at all. They're not even a full step apart. So that would not be evidence against this. It wouldn't be evidence for this. Okay, so this idea of the sample has to be far enough away. So for example, help me out here. What would the z-score be if alpha was 0.01 here? All right, now watch this. You can use your t-score chart. How many tail tests is this? 1 tail. Because there's only one way to prove greater than, and that's to end up on that side. 1 tail test, alpha is 0.01. What's the z-score? Huh? Careful, 0.01. 1 tail, 0.01. Yes, 2.326. So now you can see why you want to look at the 1 tail, 0.01, go all the way down. Did everybody find that? You're going to have to find it yourself later. So right now is a good time to make sure you can find the damn thing. So 2.326. So to show evidence for this, if that's my benchmark that I'm given, I have to find a sample that is over this many standard deviations above 9. Why does that make sense? Let me see. If 9 really is the middle, what's the probability that I get a sample that's here? Let me say that again. You know this answer. If 9 really is the middle, what's the probability I get a sample there? 1% chance. We know that. Why? Because that's the tail that has 1% in it. That's why. So if I do that, if I find a sample that is in here, there's a 1% chance that 9 is the right mean. So what's more likely? It's the right mean or the actual mean is bigger? What's more likely is the real mean is bigger. Do you guys get that, what I just said? So that's what we control. That's what the problem controls is, what is this level? And that's going to tell you what the benchmark is. All right, so let me give you this so you can at least pretend to look at it. The first step should now be really clear. But there's 4 more steps we haven't really talked about yet. But I want you to at least have this. Oops, sorry. So look at. Oh shit, that's right. I gotta make one little change to this before I read it. Once you guys get this, hold on for a second. Let me tell you what to correct on here. All right, real quick, I'm sorry. Last thing. Once you get this bad boy, do this for me. I tried to change this yesterday and I didn't fully change it. I want these switched, so make this 10.15 and this, what was it, 12.45. Just in case you look at it, I mean, I'm gonna go over this next week. Oh, and very last thing, quiz on chapter 8. Monday or Wednesday? Tuesday or Thursday?
Thursday.
Oh my god.
Oh my god. Obviously. All right, that's good.